All right, welcome again to Good Choices. I'm gonna make a good choice here and keep studying for the LPIC. It's really hard to know what is and what isn't a good choice, but I think a lot of my successes that I've had in my career, to some extent, used my certs as a bargaining chip. For pretty much for all of my career, I've had an active CCNA. I had a active CCNP pretty much for all of my career as well. And lately, I've kind of been having trouble finding stuff and don't have that CCMP anymore. And then I had those Juniper certs, of course, and I don't have those anymore. So I think to an extent, it is the industry's kind of going through something right now. But I want to make sure that my side of the bargain is upheld. So I think I think this LPIC is good. As I said, I feel like network engineering as a pure discipline is kind of um, losing a lot of value. Cloud is basically replaced, I think, 90% of. I mean, cloud is just network engineering somewhere else. And like, if you can be a network engineer that's somewhere else, great. But like even then, it's different. Like you're not doing the same things. You don't have the same goals if you're designing a cloud network as you would if you were designing a enterprise network. So it's like it's just all different, and those who don't, um, and it's easy to get left behind. I think a lot of people are kind of like people I've heard even saying like, "Oh, I'm going for the CCEIE because it might come back. It might be relevant." It's like, well, cloud is relevant now. Security is relevant now. AI is relevant now. So, yeah, it'll take you a while to get that, but like, if you think of it in terms of Vegas odds, like, do you really think the Vegas odds would be higher that uh, enterprise CCIE is more valuable than like DevNet clouds or security? Like I'd put the Vegas odds very low, and I'd put the Vegas odds very very high that even 100 years from now, Linux in some recognizable form like Bash and daemons and stuff are going to exist. Like I put the odds very very high that whatever crazy machine learning stuff there is, um, Linux, like to run it, like you will be able to run it and develop it on Linux. Um, and let me ask something of the AI quick. And if sorry, I'm kind of wasting time here, but um, what role did Linux have at Open AI in the creation of Chat GPT? So yeah, look at this. Linux played a crucial role in the development of Chat GPT at OpenAI. Linux is an open source operating system. It's an operating system. It's like that provides a powerful and flexible environment for software development. Software development isn't going away. You know, the thing is, like, these AIs might take the place of a software developer, but like they're not going to take the place of the tools that software developers use. Like they're still going to use similar methods, as far as I know, or at least for the foreseeable future. In 1,000 years, yeah, everything's going to be different. Humanity might not even exist. But in 100 years, in 10 years, I mean, in 1 year, you can get these cloud certs. You can get a Linux cert. You can get a Python cert. You can get a security cert, and you're going to be much better off than if you gotten like a service provider or enterprise networking. Unless you get lucky, then it's all different. It offers a wide range of tools and libraries that are well suited for building large scale machine learning models. Um, At OpenAI, Linux was used as the primary operating system for the development and deployment of ChatGPT. Here are some ways Linux was involved. Infrastructure. Linux is the foundation of OpenAI's computing infrastructure. It provides a stable and scalable platform for running large-scale distributed systems, which are essential for training and deploying models like ChatGPT. Training. ChatGPT requires significant computational resources for training. So this is training in the AI sense. Um, Linux-based clusters and cloud-based environments were used to distribute the training workload across multiple machines, leveraging Linux's robust networking and distributed computing platforms. Libraries and tools, and I won't go deep into all of these, but this is the biggest one for me. Open source ecosystem. Linux's open source nature aligns with OpenAI's commitment to open research and collaboration. Many open source software frameworks and libraries used in development of ChatGPT are primarily designed for Linux systems, enabling OpenAI to leverage and contribute to a broader machine learning community. So that's like why Linux exists, is because the operating system it's based on, Unix, had all these licenses and was owned and operated by a central authority that decided who and who could not use it, and they were saying only universities could use it, and even the universities, had to pay and deal with this company to do their own private things, were impeded by Unix not being part of an open source ecosystem. So that's the whole story behind Linux. That's where it came from. The goal is to make it a. Sorry, I'm going to turn up my volume a little bit here. Apologize for the volume being low oftentimes, or off oftentimes. But that's the whole point of Linux, is to allow people to accomplish their own goals without having to answer for the entity that owns the tools that they're using. It's like a hammer. It's like having to pay somebody to borrow a hammer every time. Just buy the. You should be able to use any hammer. People should be happy to lend you a hammer and not make you pay a service contract for using their hammer. Like that's a big one for me. So I think I made it clear my reasoning for going for the LPIC. I think that's really good reasoning. After that, I've got all sorts of things to go from. I mean, Cisco, I think a lot of people in tech have a soft spot for Cisco because everything's just so clear and laid out with the CCNA. There's like CCNA NetAcad programs, and you can actually get a job with a CCNA that's like a better job than you've ever had in your life. So, there's always going to be a place for vendors offering real value through their certification programs. So, the Encore is on my list. It's kind of low on my list, but the Encore is still on my list. Higher on my list is a Juniper cert, which is actually for AI. But the main one on my list is the LPIC, and I'd probably like to get the LPIC-2 and the LPIC-3 as well, but that's kind of thinking too far ahead in the future. Also, I think what might go further for me than the LPIC-2 or 3 is this certified Python. I might even be able to just take this right now and pass it without any study at all. But I think this is one. Yep, this is one that has free learning materials, free and open source learning materials as well. So not quite in the same way as the LPIC-1. The LPIC materials really are what sets it apart from just about any certification. Okay, so with that, let's not waste any more time and go into lesson 1 of 103.2. Last video was on 103.1, lesson 2. So we're on to the next one, 103.2, lesson 1. We're on the topic of GNU, which is stands for I forget what GNU stands for. Let's see what it stands for. I was gonna say it stands for Grand Unified Bootloader, but that is grub and not GNU. Yeah, that's what I thought it was. So, it stands for GNU is not Linux. So GNU is not Linux. It is an extensive collection of free software. So, like, the point is, it's not Unix, because as I said, Linux is born out of Unix being a closed off, paid for software that's not available to people for their own ends and means. So, you know, GNU is an extensive collection of free software, including an operating system kernel called the GNU herd, various programming languages, compilers, text editors, and other software tools. The GNU project was initiated by Richard Stallman in 1983 with the goal of helping a completely free and open source operating system. So I'm kind of confused about this. Why isn't Linux GNU? Why are Linux and GNU different things? Okay, so here's the answer. And it's kind of annoying. I have to wait for it to type, but Linux and GNU, so GNU is not Unix, are often mentioned together because they are commonly used together in operating systems. However, they are technically distinct entities with different origins. GNU refers to the collection of software developed by the GNU project, initiated by Richard Stallman in 1983. The goal of the GNU project was to create a free and open source operating system that could be used by anyone and provided the freedom to run, modify, and distribute software. The GNU project developed many essential components of an operating system, including compilers, editors, and utilities. Linux, on the other hand, refers to the kernel of an operating system. Now, I thought they said kernel here as well. Yeah, it said that the GNU herd. So let me ask it that. I thought GNU had the GNU had the kernel. Why kernel? KERNEL. Why are two kernels? KERNEL. Kernels needed on a system. One for GNU and one for Linux. All right, so we'll get that answer, but in the meantime, I'll keep reading this. So the goal of the GNU project was to create a free and open source operating system that could be used by anyone and provided the freedom to run, modify, and distribute software. The GNU project developed many essential components of an operating system, including compilers, editors, and utilities. Linux, on the other hand, refers to the kernel of an operating system. The kernel is the core component responsible for managing system resources and facilitating communication between hardware and software. Linus Torvalds developed the Linux kernel in 1991 as an independent project. The Linux kernel alone does not constitute a complete operating system, but rather a fundamental building block. Okay, so, all right. The combination of the GNU project's software and the Linux kernel resulted in what is commonly referred to as GNU/Linux, or simply Linux operating systems. The Linux kernel was paired with GNU's userland tools and libraries to create a complete operating system. The reason Linux and Unix are often distinguished is because the Linux kernel was developed independently of the GNU project. Although the GNU project aimed to create its own kernel called the GNU Herd, it faced delays and was not mature enough for widespread use when Linux gained popularity. Consequently, the Linux kernel was adopted by many GNU systems to create fully functional operating systems. Okay, so here's the answer. So if GNU includes an operating system kernel called GNU Herd, why do you need Linux? Well, you need Linux because GNU Herd sucks. It wasn't developed on time, and it wasn't as good as the Linux kernel. So you're taking the best of both worlds. You're taking all the good parts of GNU, and then you're replacing the bad part, the kernel, with all the good parts of Linux, which is the kernel. So, and that's the whole open source collaborative nature of this that I love. It's like you don't have, like, if it was a central authority that required licenses, you'd have to accept a bad kernel because that's the product. You can't, it's a proprietary product and you can't change it. But since it's open source developed by a community, you can take the good and throw out the bad and evolve a product or software over time that only has the best of whoever did the work. You can just throw away the bad if there's something better and use that instead, because there's no proprietary, you don't have lawyers involved to the same extent. All right, so it's worth noting that the terminology used to refer to these operating systems can vary. Some people refer to the combination as GNU/Linux to acknowledge the role of GNU in providing the userland tools, while others may simply use Linux as a shorthand. And it's kind of funny because if you use, it's almost like you should use GNU as a shorthand, because the kernel isn't, you don't see the kernel in the same way you see all the things that, the user land. So, like, I don't know why. Let me ask it that. Why isn't it more accurate to call a Linux system a GNU system, since GNU comprises a larger and more visible part of the system? Let me ask it that. I love that I can ask these questions and get an answer. I just love that. Okay, so in summary, GNU and Linux are different entities. Linux refers to the kernel developed by Linus Torvalds, while GNU refers to the collection of software, including a kernel, developed by the GNU project, but where the kernel part of it was, the best of both worlds were combined, which is a beautiful, wonderful thing that you get in the open source community, and that's why I love that so much. They are often used together to create complete operating systems, but their origins and development paths are distinct. So here's my question. I thought GNU had the GNU kernel. So we got the answer before. So the answer is the GNU does have that kernel, but you can mix and match and take the best of both worlds and combine them. You don't have to, in order to run GNU, you don't have to have every original piece of collection of code used with it. You can mix and match. So you are correct that the GNU project initially aimed to develop its own kernel called the GNU Herd. However, the development of the GNU kernel faced significant changes and delays, and it did not reach a mature and stable state when Linux gained popularity. The Linux kernel developed by Linus Torvalds emerged as a viable alternative and gained widespread adoption. The Linux kernel was compatible with the GNU project's userland tools and libraries, making it possible to combine them to create a functional operating system. This combination, referred to as GNU/Linux or simply Linux in common usage, provided a complete operating system that fulfilled the goals of the GNU project. So to clarify, only one kernel is typically used in the GNU Linux operating system. Is the Linux kernel. The GNU's project software. Yeah, okay. This is just kind of restating. This is nothing new. No new information here. We already know that. So I think a more interesting question is, why don't you call it GNU? I mean, it's mostly GNU, right? It's just the kernel from Linux. So the question of how to refer to a GNU/Linux-based operating system is a matter of terminology and perspective. Different individuals and communities may have verifying preferences and arguments regarding which term to use. The GNU's project software, including compilers, editors, utilities, and libraries, plays a vital role in the GNU/Linux system. These components provide the userland tools and infrastructure necessary for a complete operating system. On the other hand, the Linux kernel is responsible for managing system resources and facilitating communication between hardware and software. Richard Stallman, the founder of the GNU project, advocates for the term GNU/Linux. Nobody's going to say that. It's too wordy. To recognize the significant contributions of the GNU's project software to the overall system. According to his viewpoint, he acknowledges the philosophy, goals, and ideals behind the GNU project. I mean, they should call it what? They should combine these. So like Lignu, like Lignu, Lignu, like they could call it that. But like nobody's gonna say this. It's too wordy. However, it's worth noting that the common usage and history convention typically refers to systems as Linux rather than GNU/Linux. This is due to the popularity and widespread recognition of the Linux kernel. The Linux kernel has been extensively adopted and serves as the foundation for numerous operating systems, including many GNU-based distributions. Ultimately, the choice of terminology depends on the context, personal present. Okay, so I can stop reading that. All right, so our objective. Sorry, we got on kind of a tangent there, but it was useful. I think it gave us a lot of knowledge of the GNU and a lot of knowledge of Linux and why they're combined. I think that was really good to know. But the objective for this lesson is going to be to process text screams. Well, I think screams are going to be a large part of this cert for sure, but it's not the objective of this lesson. The objective of this lesson is to process text streams using filters. Processing screams, that'll happen when I actually register and take the exam. But for now, we're going to focus on streams. All right, introduction. Dealing with text is a major part of every systems administrator's job. I think they mean system administrators here. Doug McIlroy, a member of the original Linux distribution team. Let's get a picture of this guy here. I don't know. I just like putting faces to the name. So here he is, giant nerd, of course, which is great. I wonder if he's still alive too. This is kind of a tangent, but one of the coolest things I find about these sorts of things is like, people are like, oh, he was born in 1930. These are really pivotal, important people, and like, imagine if Einstein was still alive and you could like talk to Einstein. Like, this guy's still alive. He's a professor at Dartmouth and he's 91. You could send him an email and he might respond. Like, I think that's really, really cool. I think that's something people kind of take for granted. Like, imagine if Sir Isaac Newton was still alive. It's like, maybe this guy isn't quite at that level, but he was one of the pioneering researchers of macroprocessors and programming language extensibility. He had participated in the design of multiple influential programming languages, particularly C++, which is just like a pretty big one that's still used today. And not only that, he was a member of the original Unix development team. Now, this is Unix, remember. Um, he summarized the Unix philosophy and said, among other important things, write programs to handle text streams because that is a universal interface. Linux is inspired by the Unix operating system and it firmly adopts its philosophy. So an administrator must expect lots of text manipulation tools within a Linux distribution. And I think this is going to be really interesting. So let's ask it: what are some alternatives to writing a program to handle text streams? And I feel like honestly, like ChatGPT is probably an alternative to that because it handles weights, right? It handles neural networks, not. But here we go. So what are some alternatives to text streams? Okay, so binary streams, object oriented representation, uh, database systems, XML, JSON. Okay, those are not text streams. Interesting, but they're utilized quite a bit. So Linux is inspired by the Unix operating system and firmly adopts its philosophy. So an administrator must expect lots of text manipulation tools within a Linux distribution. A quick review on redirections and pipes, also from the Unix philosophy, not Linux. So this is what inspired Linux, but I believe this was kind of behind a paywall and not like Linux had to be developed to overcome some of the limitations that that Unix was representing. I want to get the big quote, or yeah, I want to see what he's saying here. This is the Unix philosophy: write programs to do one thing and do it well. Write programs to work together. And then here's the big thing we saw in the training materials: write programs that handle text strings because this is a universal interface. Here he is as a younger man, um, having a glass of Chardonnay, maybe, or it just looks like the worst kind of was it just like the cheapest beer you can possibly get. I guarantee you that is what that is. All right, so also from the Unix philosophy, write programs to do one thing and do it well, which we saw in his quote there, and write programs to work together. Those were the previous sentences in this quote here. One major way of making programs work together is through piping and redirections. Pretty much all of your text manipulation programs will get text from a standard input, output it to a standard output, and send eventual errors to a standard error output. So this is one of those things too where like I see this all the time. STDIN, ST or STD, sexually transmitted disease is what that stands for, of course. No, it stands for standard. So standard in, standard out, and standard error. It's one of those things I see that all the time. I just, winging it, copying, pasting, not understanding what it is. So this is great. We're going to get an understanding of that. So unless you specify, I'm making progress because I know this does not stand for. I know what the STD stands for this time. It stands for standard. So unless you specify otherwise, the standard input will be what you type on your keyboard. The program will read it after you press the enter key. Similarly, the standard output and errors will be displayed on your terminal screen. let us see how this works. So I think this was a key sentence, so I'm going to read it again. So unless you specify otherwise, the standard input, so this stdin, will be what you type on your keyboard, maybe from your mouse as well. The program will read it after you press the enter key. Okay, that makes a lot of sense. I was actually confused about what that actually was. And then similarly, the standard output and errors will be displayed on your terminal screen. So let's see how this works. In your terminal, type cat and hit the enter key. Then type some random text. Okay. Here we go. Cat. Just random text. All right, and now, okay, so then we gotta hit Control C, which I do not know. There it is. For more information about the cat command, the term comes from concatenate. Please refer to the man pages, or you can do the -- help. That's what I prefer, because then it's spit out into your terminal. It's not in a special thing, but you do get more information in the man page, more complete information a lot of the times. You get the copyright, so like there's more information in the man page, but if you do -- help, you usually get all the information you need. All right, note, if you are working on a really plain installation of a Linux server, some commands such as info and less might not be available. If this is the case, install these tools using the proper procedure in your system as described in the corresponding lessons. As demonstrated above, if you do not specify where cat should read from, it will read from the standard input, whatever you type, and output whatever it reads to your terminal, its standard output. Now try the following. Cat > my text file. So this is a test. I hope cat is storing this to my text file as I redirect to the output. I will hit Control C and check this. So we already went over this before. The > sign redirects the output to a file, and it writes it, so it replaces whatever in that file with there. You can also use two > signs to append to that file. So we already went through that before, but I guess I'll just do it again quick here. And I spelled file wrong, but can still cat out my file. So my text, there we go. Yep, and that's everything. Oh, that's interesting. So if you hit a Control C, then it does not take this std in and process it to the std out. It only takes the lines that do not control the escape, that do not contain the escape character, it looks like. All right, so we got that good to go. We'll get rid of that. The > sign tells cat to direct its output to the my text file, not the standard output. Okay, so that's interesting that the file is not standard output. Now try this. Cat my text file > my new text file. There we go. So you can redirect the contents of a file into another file. This has the effect of copying my text file to my new text file. You can actually verify that these two files have the same content by performing a diff. I'm going to do that because diff is like pretty awesome. It's one of those things where like I wish Windows had a diff. That would be awesome, but it doesn't. So we're going to say my text file. Sorry, we can't cat it. We're gonna do a okay. So cat > sign my text file. There we go. Now we can type in a bunch of stuff. Now on its own line, we'll do the Control C, so we get everything in there. We'll cat out my text file. There we go. We get all of the lines that were relevant because we did Control C on its own line. So now let's do cat my text file and then redirect the output to a new file called my new text file. There we go, and we'll cat out my new text file. It looks the same, but let's make sure by using diff. So my text file, my new text file using diff, and we get no changes. As there is no output, the files are equal. Now try the append redirection operator. So, alright, let's try that. Echo. And we're using a single quote here. So since this is the bash terminal, all of these are going to be literal. So if we would do this, we would just get that $sign. We wouldn't be calling a variable is. Okay, and then two greater than signs for the for appending instead of writing. All right, and let's do that diff one more time, and there we go. We've got a new line. It looks like we've got also like an ID for the change. My ID is 3A4. Their ID is different 4D3. So far, we have used redirections to create and manipulate files. We can also use pipes, represented by the pipe symbol. It's above the enter key, to redirect the output of one program to another program. Let us find the lines where the word this is found. So we can do cat my text file, then pipe one program to another program. So we're going to pipe the program cat, which takes this text file and sends it to the standard out. So we're going to pipe that result, the standard out, to this other program, grep, which searches through for matches. So the match is THIS. Let's try that here. So we're going to do the first program cat, and then we're going to feed it my text file, and then we're going to pipe it to this second program grep, and we're going to search for THIS. Oh, so I did not have any. Okay, I used different text than they used. So let's try it with some of the text that I used. So there we go. Let's search for NAF instead, because I see that there. And there we go. We got a match right here on line 2. Kind of doesn't really show you. I wish it would show the whole thing, but oh well. So the other thing we can do is -I, which it doesn't explain. So it'll explain it later, but I know what it means. It means case insensitive. So if I were to do the -I, capital N, capital A, capital F, or any combination of capital letters, it's case insensitive. So we'll just search for NAF, whether it is in upper or lower case. And I accidentally hit full screen, so I need to undo that. There we go. Okay, so now we have piped the output of cat to another command, grep. Notice when we ignore the case using the -I option, we get an extra line as a result. I did not notice that. Oh, so no. So what is meant to notice is that in their text, which is up here, this is a test. I hope cat is storing this. So they have two instances of this, but the first one is at the beginning of the sentence, so the T is uppercase. So when they match on it without it being case sensitive, sensitive, they only get the sentence that has all lowercase letters. But now they have 2 entries because it's case insensitive, so they get the capital letter first line as well. All right, so next part of this, and this looks like a really long one, so I'm going to have to split this into multiple parts for sure. It looks like mostly it's the exercises have long answers, but I might need to take a break pretty soon. So I'll try to get to reading a portion of the text file and take a break. It looks like a lot of these are just examples, so it should be pretty fast to get through. All right, so this is processing text streams, reading a compressed file. We will create a file called tfu.txt, creating a list of the following items. All right, I can do that. So let's do that. Now there's a number of things we can do. One of the things we can do is use a editor like Vi or Nano to do that. But we could also just use what we learned here. So let's do that. We're going to redirect the standard output from cat into this file txt. All right. Yep, and we want to paste multiple lines into there, and then we'll, on another line, do the Control C. There we go. So now if I cat out ftu.txt, we've got everything from bzcat down to zcat. Now we will use the grep command to print all of the lines containing the string cat. All right, let's do that. Cat ftu.txt pipe grep cat. There we go. Another way to get this information is to just use the grep command to filter the text directly without the need to use another application to send this text stream to standard out. Okay, so let's try that. Grep. So kind of doing that in a different order here. There we go. Works the same way. We'll take a look at grep to get a better sense of why that's the case. So grep takes an option and then takes a pattern. So I guess yeah, it's a bit confusing why it's not taking cat space ftu.txt as the pattern, and why it knows that this is a program. That's kind of unclear to me. Oh, you know what? It doesn't know that this is a program. See what's happening is we're searching for a pattern in each file. So what we got is grep, then the options. We don't have any options specified, just a space here. Then the pattern we're searching for. So we are searching for CAT, and we can see we've got these matches here. And then the file that you're looking through here. So we're actually not using CAT anywhere. It's kind of confusing. I wish this were a bit different. Here we are using CAT. Concatenate, we are using that program to send the contents of this file to the standard out. But then once they're in the standard out, we're piping that as a standard in, I think, to grep, and then we're searching for instances of CAT. This is different. We're not using two programs. We're just using one program, and we're searching for the pattern CAT. We're not calling this as a program. We're just searching for these characters in the file already. So that's the difference between the two. All right. Remember, there are many ways to perform the same task using Linux. There are other commands that handle compressed file. I'm kind of coughing a lot. I will have some water there. All right. ASMR for you there. There are other commands that handle compressed files, bzcat and bzip compressed files. xzcat for xz compressed files and zcat for gzip compressed files, and each one is used to view the contents of a compressed file based on the compression algorithm used. Verify that the newly created file, ftu.txt, is the only one in the directory. Then create a gzip compressed version of this file. Alright, let's do it. So first we need to verify that it's the only one in the directory. ftu star, yep, only one. And then we're going to use gzip, which stands for GNU, I believe. It's one of those userland tools. The system is mostly GNU. Alright, now let's do that same thing again. Star. Oh, and we still only have one file. That's because we actually altered that file. We didn't create a new file that was compressed. We changed to the existing file. And now it has this .gz extension, and it's compressed. It should be smaller than the other file, but unfortunately I did not do that before, so I don't have the other file to look at the size of. Alright, so next, use the zcat command to view the contents of the gzipped compressed file. Alright. zcat space ftu.txt.gz. Alright. I can't remember what it was originally, but alright, moving on. Note that gzip will compress ftu into ftu.gz, and it will remove the original file. By default, no option from the gzip command will be displayed. However, if you want gzip, not option. By default, no output from the gzip command will be displayed. And we saw that when we did gzip, we got no output, and then we looked at the results using another command, ls. So by default, no output from the gzip command will be displayed. However, if you want gzip to tell you what it is doing, use the -f option for the verbose output for the verbose output. So I'm going to do this again. It looks like we're moving on to our next section. We're not going to be talking about zipping anymore, so I'm going to spend a little bit more time on this. I believe gunzip is the way to unzip it, so we're going to gunzip ftu.txt.gz. Okay, good. And then we'll look at the ls-l for that file, ftu there, and we can see the and let's do -h as well, so it's like human readable. Oh, is that not? Wait, I'm confused. I thought you could do a -h. Maybe it's an uppercase H. That could be the case. Let's see. That could be the case of the. Yeah, -h is human readable, so I don't know why we're not getting the units. Like the units of the file size would be nice. It's not human readable to just have a 105 here, because I don't know, like, what is this, 105 gigabytes? Is that how big the file is? I'm assuming it's bytes, but if it's not human readable, it's not human readable. So okay, well, let's just go with that number 105, and let's see if that number shrinks when I compress the file. So there's the number 105. Okay, and then we're gonna do zcat. Oh, not zcat. We're gonna do you know what? I know what the command is. We're gonna do gzip on the ftu.txt file. There we go. We got no output. So now let's do the ls again, but now we need to do a .gz, and we've actually increased this number to 107. So confusing. I don't know what's going on there. That's strange to me. But oh, you know what? let's get a dash V on that, because then it might be easier. So we'll do the gun zip again on the FTU zipped file, and then we'll do the ls dash that on the unzipped file. There we go. We're back to 105. So now let's zip it again, but this time we'll use the dash V flag. Hopefully, get some sense of what's actually happening. So, looks like 22.9% of the file was replaced with that. I don't know what that means. I wish I could get like the GPT tool here, like where I could get like here as well. But I mean, I can always just go and paste it in. But yeah, okay. So I guess I'm happy with that. Moving on, we got to see the verbose output just to see what that looks like. Familiarize ourselves with that. We got to see numbers change in the ls-l. The number actually increased, which is strange. And we got to see the file extension change. One more thing I'd like to do, let's try to cat out this compressed file. So ftu.txt.gz with just a regular cat. And we can see we got a bunch of ugly gobbledygook doing that. So let's do it one more time with zcat. And now we can see the thing. So I actually didn't know that. Zcat is a way you can concatenate and view to the standard output the actual uncompressed contents of a compressed.gz file. I did not know that. That's really useful. Cool. All right, so the next section is viewing a file in a pager, and I do need to take a break here. A lot of this stuff I'm finding to be like this section is like real. Like I already know all of this. I'm just kind of beating this to death in my own mind, like in a dead horse. But hopefully it's helpful for people on this channel. So I'm gonna keep going. Should be able to get through this pretty fast since I already know it. But for now, I need to take a quick break. We're almost at the hour mark, so I actually might need to split it into a part pretty soon. But for now, I just need that break. So I will take that, and I'll be back shortly. All right, welcome back again to Good Choices. Okay, so next section is viewing a file in a pager. We're at the 1 hour minute mark very nearly, and the most I can do is another half an hour, but I'm going to keep this short. All right, so viewing a file in a pager, you know, cat concatenates a file to a standard output once a file is provided after the command. The file /var/log/sys is where your Linux system stores everything important going on in your system, using the sudo command to elevate privileges so as to be able to read the /var/log/sys file. You will see messages scrolling very fast within your terminal window. Okay, so let's get those messages going. Sudo cat var log syslog. Okay, so I don't see any messages going fast. You can pipe the output to the program less so that the results will be paginated. By using less, you can use the arrow keys to navigate through the output, and also use vi-like commands to navigate and search through the text. However, rather than pipe the cat command into a pagination program, it is more pragmatic to just use the pagination program directly. So just like as we saw, where you don't always have to use the pipe key, you can just use the actual command on its own. Because for example, this cat and then pipe, you know, grep like already does that with the text, the output of the file, like getting that output is already a feature of grep. You don't need an extra program to do that. Grep already does that. So just like with less, you don't need cat to be involved, because the like what cat does is already a feature of less. Okay, so I need to spell it right, sudo, and now we have paginated output. Alright, so getting a portion of a text file. If only the start or end of a file needs to be reviewed, there are other methods available. The method head is used to read only the first tens of a to read only the first 10 lines of a file by default, and the command tail is used to read the last 10 lines of a file by default. Now try this. That's good, because I actually didn't know about this head command, and that makes the tail command like a lot easier to remember for me, because I was having trouble like thinking like, why is it called a tail? And a tail is like in the middle of, or like it's like, well, I guess it's in the end of a four-legged animal, but so yeah, like knowing that it's head and tail makes a lot of sense to me. Okay, so let's do the next command, which is sudo head var log syslog. Alright, let's try to make that syslog file a bit bigger. I'm going to open GNS3, open a virtual lab. So we've got in the projects library, LPIC Red Hat lab. Don't want to update. I wish it would stop asking me that. So I'm going to start all the devices, and hopefully this file is blowing up now. Let's take a look. Now that's the head command, so we're only going to see the first 10. There we go. So it's a little bit bigger, still not that much bigger. So last timestamp was 9/17. So here's all the new messages. KVM, that makes sense because we're using virtual machines. So, yep, still not that much showing up in there. Alright, so, yep, I want to exit. Alright, so there we go. I did the head command, so let's keep going. Next is the tail command. I'll do that. Need to get my lab back up. Alright, lab is back up. So we're going to do the tail command now. Alright, and those are the last 10. We can see the timestamp there. So, and then just to prove it, I'll do the head again. And now we see the timestamps are earlier. To help illustrate the number of lines displayed, we can pipe the output of the head command to the NL command, which will display the number of lines of text streamed into the commands. So the NL command might not be familiar with. If you do info, I think you might be able to find that. So if you do like info pipe lines, pipe grep lines, or line. Yeah, so now we've got some. Yeah, so here's a match for NL. So this is a way you could find these commands without knowing about them in advance. Use this info command and then grep out like some sort of description of what you want to do. So like number lines, like you could like, I want to number lines. I want line numbers. So we'll say like line numbers, and you gotta wrap it in quotes. Oh, but the thing is that's it's a regex, so it's searching for them in order. So like number, here we go. Print the numbers. Print the number of processors. Now it's case sensitive, so we're missing the key result here because it's the first letter, so it's uppercase. And here we go. We got NL. So that's what you could do if you didn't know about that command and you wanted to do something. You could just basically like say what you want to do using grep, and make sure that you understand how grep searches. So it's case sensitive, but you can disable that with case I, with -I, and then it is matching on a regex. So if you want to search for the word lines, if you want to search for the word numbers, I think searching one at a time is probably better, because otherwise you'd have to do a complicated regex to make the order of the words not matter. And you can use ChatGPT to do that, but overcomplicating things is generally not the best idea. Okay, so sudo head var log syslog pipe NL. Now we get the number of lines showing up nice and clear up here. And you can see we only have 10. And we can do the same by piping the output of the tail command to the WC command. Interesting, which by default will count the number of words within a document, and using the -L switch to print out the number of lines of text that the command has read. So okay, that's just for the to count things. We can also use tail to number the lines in the same way. You can see we've got 1 through 10 there. But in addition to that, you can use WC. Now WC, the first number is the number of lines, but you can narrow it down if you're doing scripting or something you don't want to deal with cleaning up the output. WL just gives you that first column. So I'm pretty sure WC, let's see here, you can get the second and the third column in the same way. Just use the -- help if you ever want to figure that out. So -L was lines, so we can also get the cars and the bytes. So let's try that. So we're gonna do -C, and we got 979, so that's the last. Then we got -M. Now we got 979 again, which is interesting. And then let's do -W. Okay, now we got this middle number, and then we already know that -L is this first number here, the number 10. All right, moving on. Should an administrator, but of course, sorry, you. Oh wait, yeah, that's the count. So ln just lists numbers each line. WC, so ln and WC do not have overlapping functionality. Should an administrator need to review more or less of the beginning or end of a file, the -N option can be used to limit the command's output. I hope they talk about -B. No, they don't. Okay, I will go over -B. So -N. Let's take a look at how many lines are in this. So it was -L. So now that's in tail. Now if we do cat to see the whole file, we see we got 19. Let's say we only want to do the first 3. So what you can do is, okay. Well, let's say we only want to do the first 3. So one thing we can do is head var log syslog, and then -N3. Or the order's wrong. -N, and I don't know if -N is a valid option for head. I know it is for tail, but let's try it. And there we go. We only get the first 3. Now let's say we want to get the last 3. All right, so there's the head and tail of an animal. The head is at the front, the tail is at the back. So here's the last three by using tail dash n. But from what I understand, there's another switch, which is dash b. You know what? This is just needlessly confusing. I know dash B is a valid option for something I'm thinking of when it comes to reading the files. I might be thinking of a Juniper device, actually. That's probably going to happen a few times because Juniper uses FreeBSD Linux, so it's kind of similar to this, but there will be some differences there. So I think I'm thinking of a Juniper device. So let's not get confused, and let's just remember that head is the front of the file, tail is the back of the file. So if you want to see the last three lines, you got to use tail dash n3. If you want to see the first three lines, you would use head to designate the front of the file, dash n3. Okay, so the next section is the basics of SED, the stream editor. So this is kind of a whole nother topic. So I think, yep, 1 hour mark. That's a good length of time for these. So I'm gonna split this into part two. Part one, we learned about just kind of the basics of the CLI, some of the built-in tools that are in there, WCLN. We learned specifically head versus tail, which is great because I couldn't remember like the command to see the end of a file. I just couldn't remember what it was, and it's tail because if you think of like a cow, the head's at the front, the tail's at the back, so it's like really easy to remember. We learned about appending. We learned about writing to a file. We learned about different ways of processing the output of files. You can cat the output and pipe it to another command. You can just feed into that command the file if that's a feature of that command. We learned about zipping a little bit, about how to look at a file that's zipped. You can use zcat instead of cat, and you can see the contents of a gzipped compressed file. And as an extracurricular, we learned about the difference between GNU and Linux. Linux has a really well-developed kernel. GNU has a really well-developed everything else. So since it's open source and there's no licensing or central authority that owns either of them, they can agree to mix and match and take the best of both worlds and make the best end result possible without any caveats or lawyers involved. All right, so that's it for this video. Thanks for watching, and see you in the next one.